Um, Good evening, all the participants. Welcome to QuantumATK Workshop. Uh, we planned this for more than 2 weeks workshop, so almost all the coming evenings we will sit together and learn new things. Uh, as it is a beginning, let me give few instructions, um, especially how we planned the workshop. Before that, um, let me give a brief intro of the research center, SAS Research Center. Few of the participants are already attended a couple of our workshops, so this intro is much familiar to them. But there are a few participants, they are very new to our forum and our research center. So it's my duty to introduce who are we and what are the things we are doing. Um, SIA's Research Center, uh, Spark Institute of Advanced Sciences, that we established more than 3 years before. And we constantly doing workshops and training programs and short-term research projects and a couple of other things. So here I'll give an intro of what we are doing. Um, So we started this research forum with some discussions, some research collaborations. Then we thought, okay, we'll do some training programs that helps for the research, especially chemistry and physics domain people. Then the trainings and workshops, almost all the every month we used to conduct at least one training programs based on chemistry or physics or biology. And apart from this training, we are giving the research a short-term research programs like 2 months, 3 months research training program, both online and offline. So here there will be a supervisor, and supervisor will guide to finish the program project. And mostly it is the projects are focused for PG dissertation. Apart from the short-term projects, we organized a couple of conferences and seminars, both national and international. Um, yeah, so these are the couple of brochure for the research project. As you can see, 2 months research internship on computational physics, chemistry, and biology. And we have a mentoring program here. Apart from so the previous one is a supervisor student interaction, but here there will be a mentor, and mentor will guide or help you to rectify the issues that you are facing in your research domain. So again, it is a one-to-one interaction. So you can, the previous one, there is a problem. However, here in the mentoring program, the uh, person, they have a problem, they have a research problem. However, they are facing some difficulties in executing those problems. So the mentors will be a subject expert in that field. They will help to rectify those issues. Um, And another domain that we are working is a publication site. Mostly we publish science-related articles, magazines, and books. So these are few books that we published in 2024. As you can see, it's in various domains: data science, education, the normal, the fiction writing, and the Western education, including all the science related topics. So this is the overall thing that we are doing in the last couple of years. So These are the summary. We almost organized more than 35 events, and nearly 3,000 participants already enrolled for various programs. And as I mentioned, it is a forum. Almost 100 members are there, including faculty and student members. And we do collaborate with other institutes for hosting various programs. So these are a couple of our collaborators. As you can see, some universities, industries, and other science societies, and various colleges. As I mentioned earlier, we people can take the membership, both student and faculty membership. So the details you can find in our website. Definitely, we'll communicate these details with your email. So that's about a short intro of the research, the research center. Um, Now it's time to give an overall view of the program, the workshop. I hope you all received. I hope you all received this file, the course plan file. Um, all the meeting links you can find it on the file. So today, here we are, 24th June. Most of the sessions we planned it around 7:30 time. And today's topic is introduction to SPC and computational calculations. And today we have some Xavier with us. He's from, definitely I'll introduce him before creating him. So the point is, you can see all the schedules from this. Um, so uh, the meeting links, the topics, the dates, those things you can find in this video. We already circulated with all the participants, but still, if you didn't receive this thing or if you missed this thing, please let us know. Anyway, we'll circulate this one in WhatsApp group too. So the first 5 days, the first week of our program, Sanu sir is handling. And as I mentioned earlier, today is just an introduction day. We will give an overall picture of what is computers, how we can, some very fundamental things that we have to know before starting the computational chemistry of physics. And the other two resource person, Deepak and Ayush, they are from Integrated Microsystems. Both are application engineers, and definitely will give intro during their sessions. And other general instructions, we will provide the recordings the next day. That means if today is the session, you will get today's recording and tomorrow, tomorrow morning. So you can expect those recordings. The recordings we will provide in YouTube. So if you registered, and we will give the access to the registered email ID. So if you registered with your institute email ID and that email ID is not supporting the YouTube or Google, we are requesting to share your personal Gmail ID, and that is easy for our communication purpose too. Yeah, and the very last day of the workshop, we are dedicated only to the doubt clearing session. So the yeah, we dedicated one session just to clear the doubts and the issues during the calculation. And another important instruction is related to HPC. Some of the participants already paid HPC access fee. As you know, this is QuantumATK is a software, and it's a paid software. We have to pay some. Yeah, it's a paid for. So some of the participants institute may have the access to the QuantumATK, but it seems many participants are very new to this field. We asked the survey in the WhatsApp group. and we observe that most of the participants are they are just starting the computational calculations. So if you don't have the access to QuantumATK, then you definitely need HPC access. Without that, it may be quite difficult to follow the things. See, this is not a lecture here. Tomorrow onwards, we are doing some software and some things. But to do those things, to do the software, you need a software to handle. So HPC will definitely help you in that. Sanu sir will explain other details related to HPC. Or if you have the QuantumATK access, that is enough, more than enough. However, make sure that you have access. Yeah, so these are the basic instructions we want to convey. And let me start the session, and let me invite Dr. Sanil Savior to the platform. Sanu sir currently working with MG University, Kerala, MGIF, with the Paramastra team. So they have a SPC access the the external people can use. And he worked as senior project fellow at Indian Institute of Space Science and Technology, Trivandrum. And he worked as a project trainee at Pitlight R&D, Ateri, Mumbai, and Seed R&D, Ateri, Mumbai, etc. So currently he is working with MGIF Kerala. And he was our mentor or the resource person for Goshen program too. Some of the participants, they already attended Goshen program, so they might know him. So with this short intro, let me welcome Sanu sir to the forum, to the platform. Sanu sir, are you here?
Yes.
Over to you, sir.
Yeah. Thank you, Dr. Sabil, for briefing all these sessions. And good evening, everyone. I think everybody wants to know about this QuantumATK module. And today we are covering about what is HPC and what is the advantages or disadvantages of using QuantumATK over. I think many of you familiar with Gaussian and VASP modules. And what is the difference of using QuantumATK and what are the peculiar things you can perform with the QuantumATK? That is the surface we are going to discuss by today's module. And I want an interactive session. So how many of you familiar with high performance computing system? Have you ever used this any of the high performance computing system in your colleges and this thing? Yeah. Hello, Shrestha Gupta. This session is just started. Hello. Yes, someone of you can respond. How many of you familiar with a high performance computing system?
So we are not. You have to start
Okay.
on your
Okay.
scratch.
Okay. If one is lacking, then I will start from what is the HPC. I will just explain. Okay. 1 minute. I'm sharing my screen. Is it visible?
Yes, sir.
Is it visible? Clear?
Yes, sir. Yes.
Okay. Okay, so today we are going to discuss about what is HPC and what is the advantages of a high performance computing system over a normal desktop or a normal laptop or a high-end configured desktop system, and what do you mean by QuantumATK module, and what are the benefits of using QuantumATK module, and what kind of problems you can solve through QuantumATK modules. Okay, first we go through an high performance computing system. So this outline covers introduction to HPC and how to architecting an HPC system and approach to parallelization and the parallelization paradigm application in area of science and engineering. Okay. Uh, High performance computing system means, how many of you heard about familiar with i5 system, i7 system, i9 system, and Razer 7, Razer 3? Have you any of you familiar with the CPU processor offered by Intel and AMD? Hello? Yeah, you can speak. It's an interactive session. You can speak.
Yes, sir.
Hello?
We
Yeah.
are, sir, we are
Yes,
familiar.
sir.
Familiar, no? Okay.
Yes.
So this is like that. We are using a set of, if you are using a i5 system, i5 system is having a CPU cores of 6 CPU cores, and threads we can have 10 CPU threads in multiple by 2, and 10 CPU threads also available. So it is architecting like that, how many type of job each CPU core can take. So it will faster your computation. Suppose you think, if your system having 80 electron system or 50 electron system, 30 electron system, and you are doing multiple iterations. So this iteration you can perform by different CPU cores, and your resources are so big, then you can complete your task for less than, is it depend upon the CPU code's number of threads. Okay, so that's why the high performance computing system differs from a normal desktop system. And other thing also, you have to optimize your algorithm also. Sometime what happened, your algorithm is poor and you have a big architect HPC. Anyway, you are submitting your job getting failed. That is happened because of your poor algorithm design, poor software architect design. So both should be in a single pipeline, or both should be converged, both should be optimized, then you will get a best result. So high performance computing means like that, a set of a computing technology for vast numeric calculation. So here we are performing a numeric calculations like a modeling and data processing, and employed for specialized application require a lot of mathematical calculation. So you are familiar with, in today's session we are covering with the density function theory, quantum theory, and a different artifact theory. So in every theory we are approximating the molecular orbital by a set of functional algorithms. So these mathematical functions you have to solve it. So these mathematical function having different parameters. These parameters are iterated or calculated by different CPU cores. Okay, that's a high performance computing system. A set of resources are giantly available. Okay, it is hundreds of PC or thousands of PC in a single location, and you are submitting a job in that location. That is a high performance computing. So high performance computing also can use parallel programming also, because a set of CPU cores you can use it a parallel, and it is facilitated by open MPI process that we will discuss in later. And we have a supercomputer system in this world. So the supercomputer in 90 and 80 is a custom built computer, very expensive. So after that, they built the different kinds of data center, and a lot of technology is also adapted. So when we combine to the supercomputer in the world, it's a Oak Ridge Leadership Computing Facility in Tennessee, in the United States. It is the best supercomputing is available. And in India, this available is a Cray computing system, this Advait. So it's a supercomputing system is available in India. Anyone of you heard about CDAC system? So Pune, Paramshavak system. So these all are government funded supercomputing labs. Okay, so here you can submit the job and you can do it. But one of the disadvantage of this kind of a system is only accessible to peer members, peer researchers, but not for any individual. So this kind of system is lacking to access by many of the potential users. Now, why we developed like a MG Innovation Foundation in-house in Mahatma Gandhi University. What is our motto is like that, the high performance computing should be accessible to all research enthusiasts, because anyone want to do any kind of simulation related job, we are not stopping, we are not blocking them. So we are giving the access as a different plan. It's a basic plan, advanced plan, professional plan. We are saying very little amount, we are charging, and we are giving the experience of how you can do the computation. And the computation is in a different kinds, like a CPU based computation is there, GPU based computation is there, and CPU based computation, CPU, GPU computation. So different kinds of set of computation you can process. So how many of you heard about image processing? Now the keywords: artificial intelligence, machine learning models. So many of you heard about this keyword, but you don't know what is the algorithm behind, and what do you mean by AI, what is the potential. How many of you heard about this kind of keywords? Could you please speak?
Yes, we heard about it.
Yeah. So but because we need that facility to experience, but many of the institutes not giving the experience. So MG Innovation Foundation and this research forum, this our goal is to give an experience to you, and what are the new software tools are available, and how you can perform this AI can perform in molecular simulations and genomics data, business analytics, everywhere AI can apply. And it not related to computer science student. When came into AI and machine learning, it can be applied to everything. Even language people also taking, literature people also taking. Any one of you heard about natural language processing by ANN method, CNN method? So everywhere our mathematics, computer, and the core science is now in a hand in hand. So, and this is facilitated by this high performance computing system. Okay, so what are the components of a cluster? So any HPC or a data center, many of you heard about in your IT center is having a data center. What do you mean by a data center? Data center means like that it's having is the same PC, same CPU, same memory, and same RAM. Everything is available, but is for different purpose. So everything, because some CPU nodes we are comparing for login purpose, user login authentication purpose, like OTP generation, and like kind of this parent file and cross match checking. So that kind of a files we will call as a login nodes, and the pseudo user making. So a lot of things are there. So we are using as a login nodes. And the other thing is for OS installation, operating system installation, like Linux, Windows, Ubuntu, like a Debian. So these kind of things we are going to say boot servers or a management nodes. And the other thing is for network purpose, like a firewall. Any one of you heard about Fortinet, Sophos? These are the primary firewalls, and these are associated with the network switches also. So everyone, and the other thing is a AI node, artificial intelligence node. This is for image processing, business analytics, but the same hardware is same. And the GPU is for another this CUDA programming and other kind of work. So these different CPU nodes and GPU nodes for different purpose, and everything in a single premise altogether. We call it as a cluster. And what do you mean by all data center is associated with a network gateway, and network gateway is accessible to a specialized access to public and a specialized gateway access to client. So there is a administrative access, and there is a client access, and there is a guest access. So different kind of security policy also you can implement through network gateway system. Just I'm explaining what are the components of a cluster. And HPC means it is not a single machine. This is a pool of machine for different purpose, and all together we call it as a cluster or high performance computing. Okay. And this is some of the layers of cluster software stack. We are comparing the Cray cluster attacks. There may be the HPC programming tools are available, and because it's having a master node. Master node means where the operating system and like a Windows, Debian, Red Hat, everything is installed, and in that we are installing all the application like a QuantumATK, WASP, MATLAB. All these applications are installing on a master node, and other is a computation node for only for the iterative purpose, computational purpose. And there is a image processing node, AI node. There is a GPU cards are involved. Like GPU cards means V100 card. Now the new card is NVIDIA H200 card. So single card is cost about some 12 to 15 lakh rupee. So creating an high performance computing system is very giving a capital cost to this the institution. Maybe one time setup cost may vary from 20 CR to 50 CR. So that is the cost, and that kind of a security also we have to enable. So that's why many of these IITs and ISR not giving an access to public. So that is the limitation of high performance computing, because many of the people will upload different kinds of file. So every time malware generation, malware threat attack, cyber security, portfolios, so everything we have to identify. So without doing that, they simply blocking the system. And after installing, implementing this much capital investment to this institution, our public money, we are not getting benefited to this. So for solving this problem, this Paramastra is happening. So Paramastra giving as a URL based domain access to every public, and you can upload onto your directory. So we are creating a separate kind of a directory for you, and it is a virtual environment type of a system. It will affect on your file system only, so it will not going to affect other systems. So that also I will explain. So these are the different programming tools you can do computation, and there is a job scheduler is also there, and open source is a Slum, Lustre, this kind of a, and Bright, this kind of software. This kind of a, these are the open source and the paid software. So like that, we have made one job scheduler, that is a Paramasta job scheduler for doing that kind of a job. And the others are the operating systems and drivers. These are the basic components of a HPC software stack. And why we use parallel computing? Overcome the limitations of a single CPU system. Single CPU based system means if you have a i5 system or i9 system, you can convert into 10 threads or 20 threads jobs, and each CPU thread may be allocated to one kind of a job. Instead 20 thread doing a single job. So each CPU thread, so what you can do, this is a parallel programming means one is taking an initiative of one job, and two is doing second job, three is doing third job, fourth is doing fifth job. So maybe coming to ninth processor is combining the result of 1 to 8 and is compiling all the data. So the processing time, it will be get saved, and you will get a more optimized data, more faster data. So that is what is the advantages of parallel computing. And what about this Paramastra high performance computing? So we can do this bit level parallelism, instruction level parallelism, task parallelism, and superword level parallelism. These are the different kinds of parallelism, how you can parallelly connect to the CPU threads and you can perform much faster jobs. These are the topics you don't need to understand, but I'm just giving the words to remain in your mind. So when you're hearing this kind of words, just giving an understanding. Bit level parallelism means like increase the processor word size, which reduce the quantity of instructions much. Instruction means your algorithm, this code. A processor must execute in order to perform operations on variables greater than a length of a word. When one is the instruction level parallelism, the hardware approach upon a dynamic parallelism. Task parallelism, a form of parallelization of a computer code across the multiple processor. These are the topics, don't need to take it into your mind, but it's just a hardware things I'm doing. And a parallel paradigm is like that, paradigm like that. Each processor has a unique work to do. It's an ideal situation. Communication among the process is largely unnecessary. All processes do equal work. But this is an ideal situation. But it's not like that. If every CPU cores depend upon, otherwise you can append 1 or 2 CPU cores for a particular job, and you can decrease 1 or 2 jobs, and these jobs can be mathematical functionally. You can simulate, and you can find it out a much faster data. That is depend upon varied upon your job input level. And if you are doing big data analytics or like kind of image processing, artificial neural networking, and this kind of a situation, you need a parallelization paradigms, different parallelization paradigms you have to adopt. These are no need to understand. And it's a massive processing power introduction, is a input output. These are the different kinds of processors and GPU. Because if you are selecting a CPU core, maybe how many of you noticed about what is the clock speed of a CPU and what is the cache memory available to that? This cache memory really contribute to your mathematical calculation much faster. If you have a more cache memory, you can do calculation much faster. So these are the resource allocation and resource architecting while you are performing an high performance computing. And there are different kinds of file system also there. SAS file system, NAS file system, PFS file system. So in most of these data centers, they are using NAS storage. NAS storage is a very, very inexpensive storage. And like kind of a high performance computing system, they are using a parallel file system, that is a PFS storage. It can process the data much faster, rendering much faster. Maybe you have heard about the keyword like that, rendering. So this rendering, you can perform as a kind of a operation. So your image or your thing is getting processed in video mode. So this kind of rendering is performed by your GPU card. And if your GPU card and your data transmitted by a data center is a PFS system, then you will get a good in a less time you can compute much faster. Okay. And this is the just a nutshell of Paramastra high performance computing system, which is in-house in MGIF, MG Innovation Foundation. So it is the first AI driven high performance computing system in India, and it is the first hybrid system which is installed in India, and it is a joint project with Amazon Web Services and Altair PBS, and we are launched in January 5th. Okay, and this is a thing like that. Paramastra you can access through two modes. One is the on-premise mode, that is a normal access, and other is the hybrid mode. You can what is a hybrid mode means the environment like that. Maybe your application is installed in our chest, but you want to experience. Suppose our system is having a V100 card GPU, and you when you are scrolling in AWS or Azure or GCP, this is Google Cloud, Alibaba or something, then you find it out there's a H200 card new GPU is available in there. Then you can select that GPU and perform that job there. But you no need to understand GCP and no need to understand this Azure, no need to set up or AWS. Just a drag and drop features are available in Paramastra. That is a hybrid mode of Paramastra. That is a some tier 2 level of computation. And while coming to, we are just coming to topic of QuantumATK. Okay, today we are going to discuss about why we chose QuantumATK and what kind of a job you can perform through QuantumATK. So I think many of you familiar with Gaussian, many of you familiar with the WASP module. I don't know, but I'm assuming like that. So in Gaussian, mainly dedicated to organic molecules. Like you perform DFT calculation, maybe TD-DFT calculation, maybe you perform molecular dynamics calculation, but all are not crystal kind of data you are performing, and your electrons are much limited also. Maybe you are performing some 300 type of 300 electron system, 400 electron system, but it consume more hardware resources. So, and other thing is like that, when you want to do heterogeneous type of calculation, like if you have a organic material and over a inorganic material, then you want to calculate some force field, and you want to calculate some dispersion factor. This kind of calculation you can perform through, and transport calculations. These are the type of calculation you can perform into QuantumATK. And other thing like that, have you heard about the semiconductor industry? In semiconductor industry, mobility is more important. The whole mobility, electron mobility, and when you are designing a transistor, like if you think about thin film transistor and MOSFET devices, I think someone of you familiar with the MOSFET devices, now? Anyone is familiar with the field effect transistor and that kind of devices?
Yes.
Yeah. So these kind of devices and IV profile characterization, IV generation profile characterization, CV characteristics, IV characteristics, these you can simulate through QuantumATK. And and more than other, you can do with a work function calculation, band gap calculation, and these are the peculiar things you can perform through QuantumATK other than this one Gaussian. So Gaussian is much limited to this molecular level, and this is much intended for bulk configuration. If you are in a periodic boundary condition, you can build that. You can build a bulk configuration, or you can create a layer structure. Here you can create a carbon nanotube, multi-walled carbon nanotube, single-walled carbon nanotube, and over that how the adsorption is happening, and maybe water purification is that kind of a study, which anionic thing is adhered to the membranes study. So this kind of a calculation you can perform with a QuantumATK, and this makes a difference with the Gaussian. But one of the disadvantage of QuantumATK, you can't do any photoluminescence characteristics. That means you can't do any TDFT calculation. Okay, you can only perform DFT calculation, not a TDFT calculation. So you can calculate the absorption factor, not the photoluminescence factor. That is a limitation of QuantumATK. So other thing is like that, if you are incorporating your own script, that is another additional feature, because everything is built in a C++ Python file, this all back file. So QuantumATK provides an additional library. You can modify the existing script by your own as a correction factor, and you can apply your theory. Because how many of you heard about the Python NumPy, that scientific calculator? Any one of you heard about Python NumPy?
Yes, sir.
Yeah. So by using Python NumPy, you can do matrix iterations and everything, and that data you can input into QuantumATK. So that makes is a really flexible tool. And as a research student or a research candidate, you can see that most of these QuantumATK papers is published in physical review letters. It's a PRB, PRL letters, and Nature also. This QuantumATK citation is happening. So people are much interested in this kind of activity. Okay, so here basic things they are doing like that: density function theory, empirical type binding, classical and machine learned force fields. Because in Gaussian we are limited to some kind of a force field. There is no provision to, there is a provision by custom, you can select and drag and drop, like this kind of force field you can input it. But here you can customize design that force field. Different kinds of force field also you can customize it and design it, and you can publish a paper in a force field itself. There is a force field calculator is existing in a QuantumATK module. So when you looking into the QuantumATK, this QuantumATK is an integrated platform, electronic and atomic scale modeling tools written in basically in Python and C++. That's way it much flexible and much easier to understand, and it gives you access to a powerful set of simulation engines. Okay, when you look into the workflow of a QuantumATK, first step is create a atomistic structure. That is the first step. And second step is set up a simulations. Third step is run a job. Fourth step is analyze result. This is the basic workflow of QuantumATK. What is the first is you have to build an atomic structure. Second is set up simulation strategies, that what you want to calculate, like which basis set you have to select, and which energy you want to calculate, and which force field you want to select, and which configuration, bulk configuration you need to select. All these parameters you are inputting in a setup simulations, and after that you are exporting to a workflow, run a job. After that you are analyzing the result. Okay, then QuantumATK installation comes with the two executables, ATK Python and QuantumATK. This is a two executables is coming. There is a script mode. Okay, when you is there have you familiar with the DFT calculations? Otherwise, I can shift to software. Um, I think everyone is understand about what is the density functional theory. Have you familiar with the density functional theory?
No,
Is
sir.
it
No,
huh?
sir. We are not.
No.
No, sir.
Okay. So density functional theory, when we are going to explain here, we are explaining the story of DFT, how the DFT comes, how DFT work, and what is the inference, what is the basis set, and how many of you not heard about basis set also? You are not heard about basis set, because it's a very vast topic you have to cover. Then any one of you heard of not understanding the basis set? I have to take the class of basis set also. Hello, is there?
No, sir, I did. I don't know about it.
Yeah.
Okay. Then tomorrow I will extend my class to basis set also. So today I'm giving the density function theory. Okay, this Nobel Prize in Chemistry in 1998 is by the development of density function theory. This Jordan and Walter Kohn shared of this basis set, because before that what they told, like, that's a Schrodinger equation. I think Schrodinger equation, at least you heard about. What is a Schrodinger equation? Hello? Schrodinger equation?
Yes,
Uh,
sir.
yeah. Schrodinger equation, what is the problem of a Schrodinger equation is like that. You want to every and each atoms you want to calculate and do that. That is very difficult in to visualize a molecule in a molecular level or in a system level, because very hard to solve. That is a Schrodinger equation issue. There's some models atoms, some molecules already, but when you're going for a big molecule and a big electron system and solving the Schrodinger equation for each atom, it is very difficult. So the people think about how you can, the many body problem, how you can solve by a different model. That's the evolvement of a density functional calculation. That is how they evolved it. So it's a position of an atom in the system, the atomic coordinate, and basis set is a set of functions used to represent the electronic wave functions. Now, without considering the electron structure, we consider as a electronic wave function, and we also consider about exchange correlational functional, a mathematical expression describing the correlation and exchange interaction between the electrons. I think many of you heard about GGA model, LDA, GGA, B3LYP, PBW, this kind of things you heard about. I think it's heard about, no? Different basis that you heard about, no? Hybrid functionals, mixed functionals. Okay, anyway, so it is a without considering each electron, we are considering the principle of a density function theory. We say electron density we are considering is a we are dispersed thing we are considering. So we will get a not that much accurate result, but it's a this as a molecular level you can solve the problem much accurate. Not that peculiarly, but you can calculate the things much faster. That is the importance of density function theory. Density function calculations are like a ab initio and a semi-empirical calculation based on a Schrodinger equation. However, unlike other two methods, DFT does not calculate a conventional wave function, but rather derives the electron distribution. That's called as a electron density function. Why the density function comes? The electron distribution that it's calculated. A function is a mathematical entity related to a function. This is nothing. It's a when we compare into this is more than this Gaussian model, but it's lower than this semi-empirical model. Basically, two ways to calculate a molecular structure. One is a quantum mechanics structure. One is a molecular mechanics level. These are the basic understanding. No need to. I will explain in detail in the coming lectures. I think I need to explain. So basically, two ways to calculate a molecular structure. One is quantum mechanics, and one is a molecular mechanics. What are the fields you can apply? As I before told like that, biochemistry you can apply, surface science you can apply, catalyst you can apply, crystal growth, semiconductors, superconductors, corrosion, mechanical property, and much field you can apply this kind of simulation calculation methods. Okay, different and now I'm comparing two different theoretical methods. Different theoretical methods correspond to different approximation to the Schrodinger equation, and each with their own accuracy, computational cost, and resource. When we compare with the Hartree-Fock system, Hartree-Fock system approach can be described as an attempt to solve Schrodinger equation for a multi-electron system by reducing the problem to set a one-off electron problems, but is a least expensive, accurate ab initio method. It was an initial method by choice of many years. That is a first evolved method, is a Hartree-Fock methods, and a second thing is a semi-empirical, an attempt to solve Schrodinger's equation. Semi-empirical methods are low-cost qualitative method. They are useful for molecules that are too large to be practical with the more accurate methods. And there is a in between, it's a density functional theory. It's an attempt to solve Schrodinger equation, but it does not calculate wave function, but rather it derives the electron distribution, electron density directly. The premise behind DFT is that energy of a molecule can be determined from electron density instead of a wave function. Schrodinger equation, what it's calculate, it's independently calculate the wave function of a each one. But instead of calculating the each wave function, we are calculating the electron density. So it's a much faster calculation. These methods include many of the effects of electron correlation. Is a modest increase in the cost of our Hartree-Fock theory. So inference from output say chemical reactivity based on electronic structure, structural properties, electronic properties, thermodynamic properties, and the different kinds of property you can obtain from a DFT. And other thing is of DFT is a basis set. You are to choose right basis set for a to calculate which system you are belongs to calculate. If you have a carbon hydrogen system, a set of basis set will cover. Carbon hydrogen nitrogen system, then a set of basis set will be applicable. So it's depend upon the which type of atom contributing to your molecular structure. So according to that, and a number of electrons belonging to, and number of valence electron belongs to, and a number of polarization, and a number of this spin orbit coupling factor. So everything will contribute to select how to select a basis set exchange correlation function. That I will take in depth in tomorrow's class, because basis set is itself a vast topic. So that I will combine with the tomorrow class. So while coming to QuantumATK module, here different calculator system is there, like this Hartree-Fock, this like a semi-empirical, like a DFT calculator. Here DFT calculator is split to two. That is a LCO calculator, and other is a plane wave calculator. This in Gaussian you can only observe density functional theory. Okay, and here you will get two things: LCO calculator and a plane wave calculator. And another one is a semi-empirical calculator, and another one is a force field calculator. And this force field calculator is not existing in, and plane wave calculator is not existing in Gaussian. And this calculator is a system performs atomic simulation, defining how we describe interactions of a electronic system. It both represent a level of theory. This is a full quantum mechanical approach, semi-empirical approach, or a classical approach, and these different algorithm settings. Both the plane wave calculator and the LCO calculator, in QuantumATK we normally call it as a LCO calculator. It is a basic calculator we are going to apply. So in the plane wave calculator, LCO calculator solve time independent quantum equations. I think many of you heard about quantum equations. Okay, so that thing you have to solve this LCO calculator. The main difference is that LCO calculator employs numerical, like means a linear combination of atomic orbitals, bulk configuration as a basis set, while plane wave calculator employs plane wave basis set. So these are the different kinds of calculator implies on calculating this molecular orbitals. There's a wave energy calculation. Another one is a semi-empirical calculator. It will requires a parameter set. Semi-empirical calculator is suitable for treating system in order of thousands of atoms. That is the beauty of QuantumATK. Here you can do calculations of thousands of atoms. When you are performing these thousands of atoms in a this one Gaussian, it will take much time. But here you can do it much faster, because this algorithm determines this is a large scale NEGF calculations. It's a device type of calculation, like a transistor and a gas sensor. This kind of devices is setting by semi-empirical calculator. Another one is a force field calculator. When you have a different layer, organic and inorganic, heterogeneous junctions, carbon nanotube junctions, and these kind of things you can make it done by this a force field calculator, and a transport phenomena. All these things. Now you are not worry about this. I'm just giving an names of this calculator. Okay, and so I think just we can go for this QuantumATK module. I'm just familiarize you this QuantumATK module. Okay, I think are you seeing this now? Hello.
Yes, 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 yes. We
Yes,
can
yes,
understand.
it's visible.
Yeah. Just wait there. So while we are opening this module, QuantumATK Nano Lab, this visualization module GUI tool is called as a Nano Lab. Here you can see this QuantumATK Nano Lab. So these are the tabs. I'm just familiarizing the tabs. This is the file. This is the project. This is the view.
Excuse me. Hello.
Hello. Yeah.
So is it possible I can get some trial version of this quantum APK to install in our computer so that it will be easy to understand? Because we will operate from your computer, but so
Voice
it
is
will
not
not
clear.
be.
Could you please, your mic is
Now
not
it is.
clear.
No, he is asking, is there any way to get the trial version of QuantumATK?
Maybe you can contact with this QuantumATK people, the site itself. Maybe they will provide a 10 days license. Otherwise, what you can do, you can pay this 3,000 rupee to CS Research Forum as a that time you will get a 1 month Paramastra access also, this software access also. Because we are not
Okay,
charging
that.
to software is free, but Paramastra infrastructure we are charging this 3,000 rupee as a is a membership access. Because
Yeah,
generally we are
that.
providing 6,000. This is a 50% discount for this.
Yeah, that will help us because when you are operating from your computer, then that time we will open from our computer so that it will easy to understand the things. Because now
Yes,
we
yes,
just
yes.
were giving visually.
Yes, yes. So this software is available. So you can contact with the CS Research Forum. So you can write a letter, and how you can get the access. You have to pay to CS Research Forum, and MG Innovation Foundation will give the access based on this feedback receiving from CS Research Forum. So all of you candidates, what I am going to explain, you have to follow that each assignment task. So if you have a QuantumATK module only, you can expertise or you can experience this QuantumATK module. Otherwise, there is
Yeah, so
no
what
importance.
I'm thinking, if you can give that access, then it will easy to take the classes.
Yeah,
If
yeah.
tomorrow
Then
you will
you,
give some class,
yeah, yeah. Then you just ask CS Research Forum what to do. Then you have to
if
register
possible,
for.
you please share everything in the WhatsApp group
Yes, yes.
so that
This
we can write
after
to
Uh,
them
this session.
shares.
no, I think sir joined little late. We'll discuss that one, sir. I mean, after he explained the things, we'll discuss that one,
Okay,
how to take the HPC access and that.
okay,
Yeah,
okay.
yeah. So I'm just explaining the things. These are the menus: file, projects. Third thing is the view. Fourth thing is the tools. Fifth thing is the window, and is the builder, and it's a help session. There is a tutorial manual. Everything is available. And in the left hand corner, you can view like there's a data, builder, workflow, job. This thing you are remembering now. This builder, workflow, job, viewer, editor. This thing I already explained in my PPT in this session, like this. Create a atomic structure, set up a simulation. Have you seen this symbols? This is atomic structure, and this is the set up a simulation, run a job, analyze the result. So this is the basic workflow. And a similar way, you have to create a workflow here. Builder, workflows, jobs, editor, viewer, and it's a custom scripted. You can append the script which is available existing thing, and this is the databases where you storing this data. And while coming to the right hand, this you can view this builder, and builder so much modules are available. This KPFM study, have you heard about work function calculation? KPFM study that you can simulate it really here. And it's a amorphous pre-builder, and there's an alloy builder, and this one interface nanoparticle nudged smiles. Okay, everything is there. And it's a bulk tools. This is a unit cell you can do, and unit cell you can grow to different unit cell also you can merge. Super cell you can do. This is the bulk tools modules, and this is a coordinate tools for the bulk tools. Okay, and there is a device tools. I already explained, the anode, cathode, and the electrode size, gate voltage, different thing. So that kind of a device you can do. And it's a selection tools. You can tag different monomers, you can tag different atoms. That also you can do. Like Goshin also, like a label. Here we are using a tag, and different visualization things. If you are doing doping and a spatial region, and if you have a this different void spaces, because it's a basic thing of a quantum ATK is like that. It is for mainly for heterogeneous system, mainly for inorganic and organic with inorganic, this heterogeneous and different layer type of a concept. And it's in a bulk model system. When we just compare Gaussian and quantum ATK, Gaussian is a molecular level and it's a device level. So different layers. Now you, if you want to build a graphene layer over a copper nanowire, this type of a calculation you can perform with a quantum ATK. It's a bulk configuration system. You can, there is a many body system you are performing here. And these are the other tools: distance, measure the distance, and translate and rotate calculation. So different analyzation. This is a bulk configuration tool. And while coming to clicking the file, you can import the file from different projects also. You can import the file. And these are the project. If you want to create a project, you have to click new, and you want to create a path. And this thing only you can practice by, if you have a software, then only you can repeat it. Okay, that I will explain in tomorrow's class. And here is just I'm giving, it is the new configuration also. You can create from your files. That means if you are performing a Gaussian calculation in that file you can really export to here quantum ATK. And that molecule you can, maybe if here you are creating a carbon nanotube and the molecule is optimized in a Gaussian, that file you can just export to here, and you can perform this interface calculation. That you can do that. And the other thing is like that, you, if you are performing a unit cell calculation in a WASP, that WASP file you can transport to quantum ATK, and here you can perform the device calculation. Molecular level you can perform in a WASP, and a device level you can perform in a quantum ATK. This is the potential of quantum ATK. And you can really simulate a device, or simulate a environment, and simulate while performing a practical study. You can just correlate and what is the gate voltage you want to verify, and which gate voltage. I don't know how many of you familiar about the semiconductor parameter device. No, semiconductor parameter device, it's a Keithley probe. It's a Keithley probe, 4 probe system. Here this a transistor IV characteristics we are taking. That IV profile you can simulate in a quantum ATK. That much level you can do that. So actually, what is the thin layer you have to develop while doing your quantum ATK, no? That you can perform through quantum ATK. So because while you are performing a device, its cost is, research cost is some 25,000, 30,000, 50,000, because you are depositing in gold, or you are depositing a very highly cost organic material. So before doing that, you perform a calculation and control the growth of this thin layer, and you can perform the simulation. So that many iterations you can really reduce it. So that is the importance of while doing this quantum ATK. And from the database you can just drag and drop the system. Okay, so here so many molecules are available in their library. You can just uh, click it. Now it is a ethane, you just clicking at, so that ethane system comes here. Okay, then if you want to rotate the system, you can just rotate the system. You can align the system. Different parameters are available, and you can transpose the system. So all the facilities are available here actually. Okay, and while we are doing this silicon carbide, let's take a silicon carbide. This is your input file. So now you want to calculate this band structure of a silicon file. So what is the small step I will explain. So first you have to select this silicon carbide from the database. After that, just right click it and send it to this workflow builder. Our second step, workflow builder. Okay, now it is the sent to workflow builder. You can see that silicon carbide is a bulk configuration came here, and these are the type of analysis tools. Okay, This is the tool I discussed before. LCO calculator, plane wave calculator, semi-empirical calculator, force field calculator, device semi-empirical, and set plane wave calculator. So different calculators are available. So what do you do if you perform a DFT calculation or a band structure calculation? Just drag and drop this LCO calculator. And what do you want to analyze? This band structure, no? So you want to go for this one and just click the band structure. Okay. So now two things came. Now you want to select the basis set. So LCO, I'm just editing that. I'm coming to here. So it's a GGA. GGA is fine for me. And basis set I took. So it's a PBE GGA potential. This is fine. No need to change. If you want to change that, then you can change from different polarization. If it is a organic model is available, then you can select a hybrid model. Okay. And polarized system, you can do that. Non-collinear, collinear spin orbit coupling. So okay. And PBB, different things are available. So you can select basis on your basis set. Okay. So just we close it, and band structure points per segment. How many points you want to calculate this one? So band structure also you do. So once your workflow is correct, okay, you just save the name. Okay. Okay. Then here is a button is there. Send the documents to another tool, and here send it as a job as a script. Okay. Job as a script I'm sending, and here save results to file. Everything is default is save results to file. Save result to file. Okay. I'm clicking OK. Okay, that also fine. So it will create that one is the directory first you have to create. I'm creating that. So I'm saving it. So now the system comes here, submission engine. Either you can do it in a local computer, other thing you can do it in a high performance computing system. Now I am doing in a high performance computing system. My system is remotely connected to my laptop. I'm performing in my laptop. My laptop is remotely connected to MG Innovation Foundation's HPC. Now I am sitting in my home, and this HPC in there. So it's a remote center. So this is just to select it, and what are the queues available. I'm belonging to super queue. Okay, I want to just click the super queue, and what is the nodes I'm going to put? It's a 64 cores I'm going to put, and just add that. Okay, now the system comes here. Then you can see that. So there is a buggy is there. Just you want to select the file, and this buggy you want to select it, and just run this job. This one, just run it. This is so much simple, this thing. And here you will get a log details. So what is happening there in HPC? So now it is happening like that, running on remote. You can see the status. It is running on remote. And once it's successfully started, here the log will automatically return. Here you can see that I put it as a every 2 seconds the retrieve the data. Now it start retrieving. Everybody seeing like that now? Hello? Hello?
Yes.
Yeah. You can see that the log file is generating. So it will keep on updating every 2 seconds. Is fetching the data from HPC. So it will fetch the data, and based on our job calculation, after the thing, everything will get completed. So dynamically, you can see that instead of a Gaussian, you want to run script and everything you want to watch from there. But here, QuantumATK and Paramastra, how we done that like that. In your laptop, the log detail automatically fetch. No need to go to Paramastra. Everything we will set up in our backend. Okay. Actual Paramastra is performing here. Just go to Paramastra. I'll explain. This is the Paramastra. Okay, you can access like that when you getting an account. Before that, just explain about MG Innovation Foundation. You can see as mgoif.com. When you are clicking, you can see as a company. It's a Section 8 company, and it's a purely intended for innovation and continuous research. Okay, we are having in the different modules. We are having nutraceutical module, Internet of Things module, app and web app development, and our peculiar thing is like that is a Paramastra HPC. just you can see this Paramastra HPC. Just you click that, it will direct it to another website, and here our services belongs to. Okay, and this Paramastra HPC can compute a different structure. We are categorized into information technology, structural simulation, molecular simulation, telecom sector, composite sector, analytics sector, different sectors we are this one is categorized. You can see this. Okay, when you are clicking molecular, you can see basic thing, DFT calculation, energy calculation, spectral observation, molecular dynamics of a small molecule, big molecule, everything we are doing. And our services, what are the softwares available, everything is done here. You have to just sign in and register for Paramastra. Have you any one of you registered for Paramastra through this portal? Sign up for that?
Yes, sir. I signed up.
Yeah. So simply what you do like that, if you are just sign up thing and make the academic, create the username and email, mobile number, password, and click the sign up. Once you sign up, you will get a username and password. And the username and password, you want to use that for this account login. 1 minute, I will just log in and explain. Mail.com. Yeah, it's a while you sign in. So if you are a paid client, then you will get you will sign in. After the sign in, after the payment, what you do now? Account registration, the second tab after the dashboard, you have to click account registration. Then you will get a academic user this thing. Here you have to fill all the details, first name, middle name, academic things. If you are a mentor, if you are a faculty, then you can fill as a mentor name as your own. Okay, Aadhaar ID, passport, what are the requirements you choose? And the type of OS is a Red Hat. See, you are belongs to only basic plan. So you are limited to up to 64, and there is no GPU. GPU you have to select 0, and RAM you can select 264, storage 500 MB, node is 1. You are limited to 1, and the HPC type on-premise only. You are not belonging to hybrid. But you can, after this usage, if you want hybrid, we will also give the hybrid. And here you want to mention like that you need a QuantumATK access. Okay, here you mention like that QuantumATK, and just submit it. After the submitting it, we will get an inquiry. So we will approve from our end by confirming the payment status. Then you will get an dashboard. Here you are all.
How much is the payment for this registration?
It's only 3,000 rupee. Only 3,000 rupee. Here our packages are we have described here. This is the actual thing. Basic thing is belongings to 6,000 rupee. With a Paramastra, there's a PUID. There's a virtual desktop if you want. Then it's a 7,000. It's a different case. No need. And advanced plan is 128 CPU cores you will get. That is 17,000, but it's for 3 months. Another one is the professional plan. That is the 28,000. That's for 4 months. And everything you can see like that. There's a coin is available. 3,000 coin. It's like a mobile recharging system. Okay, if you are using a 1 CPU core per second, you will charge about 0.001 rupee. That much less, but it's much enough. This 3,000 is much enough if you are a basic user. This is 6,000 we are offering for 3,000. 50% discount for these webinar users because you are using for the first time. So we are giving the 50% discount. This is the package you are belonging to while you are paying this 3,000. 3,000 you are paying, then you will get a 3,000 coin for your computing calculations. Okay, so and you can view your usage details here. Type of job, job ID, used node, used core, and how many coins is used. Every time you can watch like that how many coins are exhausted. That thing how you calculate like that. This is the each job. If you are running 11017 job, if I am, that is another script that is like that. 1 minute. Okay, so if suppose it is our job is running, and you can see the all the details here, how many cores you are used, and which core you have run, which date you have run, which time you have completed. and this is job only took 3 seconds to complete. Okay, and you can file this output file. If you want this output file for future communication, just click it and download it. It will download to your local PC as a file. Okay, this file you can view for your purpose. And the QuantumATK, same model you can work it on, but a QuantumATK what we have configured, this is no need to access this Paramastra. Only you need this the job is completed. You can see like that. Okay, job is completed. Now we are go for the job. After the job is completed, how you can view the job? You just click the lens, this data. Okay, and you have to search your name, SIC2 result HD25. This is your file, and the band structure is like that. Just click it. Now this is the band structure. This is the direct band gap. This is the indirect band gap. Okay, so these are the points. This mesh points. You can see that it's a mesh points. Okay, this is the basic way of doing computation with the QuantumATK, and you no need to, after getting this Paramastra username and password, you no need to log into this Paramastra username and password. You can just use this QuantumATK module. Is automatically fetch from Paramastra. Only you want to use this Nano Lab module. This software, whoever paid to 3,000 rupee, that we will share through CS research forum. They will share a link. From there you can download this software, and this installation step also we will mail you. Okay, then how to install this software, how to configure it. So according to that, you can configure the software, and you can experience what is QuantumATK. So this is the basic understanding of QuantumATK, and each band structure and everything I will explain in the next class. I think this is the basic introduction of QuantumATK. I think everyone now is familiar what is the potential of QuantumATK. And other thing is like that. Okay, that result I can show from here also. These are the result. Now you can do compare the computation. This is the, you just compare the value. This is the 4.548. This is 1.3435. This is the same thing I computed here also. You can hear 4.48, 1.35. Have you seen that? Hello?
Yes.
Yeah, sir, directly I have done the computation, and now the comparing the PPT data with the computation. Okay, for just experiencing. So that much repeatability is there for this computation purpose. Okay, and while you are doing this QuantumATK computation, as per Gaussian, you are to cite this many papers. That is mandatory. You are to cite these all papers of QuantumATK while you are submitting your manuscript to any of these publishing journal, these scientific journals. So this is some mandatory things. Okay, so today's session is over. Anything is, do you have any doubts? You can arise.
Yeah, for
Hello.
next class, I think you need the access to a. Hello.
1 minute, 1 minute,
Well,
1 minute.
For the next class onwards, so if you can give the access, you can email that how to download that automatically. You can
okay. Let.
Sabil sir,
Yes,
what
yes,
he
yes, no, he's asking how to download QuantumATK. One, please understand the one thing, as Sanusa said just now, it is not like the other software. You don't need to download it, or maybe Sanusa can explain a little more.
Yeah, it's a,
that access, that access.
we will
I'm not
give
talking
you.
about the download. You give the
Yeah,
access that we can access this, and we can operate. While you are taking the classes, we can operate from our computer, so that it will be handy for us, so that it will be, we can
Well,
do the things properly.
yeah. Sure.
one thing, there are three categories. One, some of the participants, they have QuantumATK in their institute. In that case, they can use their QuantumATK. And the others, they don't have QuantumATK with them, and some of the participants, they already paid HPC access. So maybe coming days, Paramastra team will contact them and they will give instruction how to activate that one. Maybe tomorrow itself, right, Sanu sir?
Yes, yes. Whoever paid this thing, while then we can set it up, because it's not that much easy. Because while we are doing this computation in a high performance computing, license server is fetching from high performance, and the software is running in your local PC. As such, I shown. Na? So you have to set up different configuration settings in your system. Just I will explain like that. I will show you how to do this.
And another, some of the participants, it seems they installed the trial version. So I don't know how many. Some of the participants they mentioned while interacting with them, they said they installed. They already did all this, the trial version from the QuantumATK website. So is there any participant like that? They
So I have trial version.
Okay.
But how do I connect that for the HPC? Like, does HPC work with trial version?
No.
No.
What is the thing like that? This software is cost about near 18 to 25 lakhs rupees. Okay, it's not it's a silly software. It is a 18 to 25 lakh rupees software, and here the license we are only giving to academic and academic research purpose only. That is our limitation also. That's why university is giving the access, like MG University is giving the access to your, as a webinar content, we are giving the access. So this license server every time belongs to this Paramastra HPC. You will get an, what is the thing like that, you will get a download file of a particular extension that is encrypted in that download file. If while you are downloading from general public network, it won't support actually. What are the package we are giving, that thing you have to download. We will provide you as a, in a drive we will share, the CS research forum will share that thing you have to download, and that is a configuration file also we will provide you. That also you need to install. Then only the connection happens with the Paramastra. Okay, it is not like a trial license, it's a full license, full-fledged. You can use for 30 days any type of calculation. It's not limited. Okay, we are giving a full-fledged license.
But
So
Sanu
my
sir,
doubt is,
okay, Sujit,
if
please
I
go ahead.
already have trial license, do I need to remove it to install this the
Yeah.
configuration?
That package you want to uninstall it, and
Okay.
fresh installation you have to do. Okay.
Thank you.
Sanu
Okay.
sir, one more question along with this. So if they install the trial version in their computer, whether they can do the calculation with that, or
Yeah, but it is a very much limited, sir.
Okay,
It is not open to every calculator won't work.
okay.
Yeah.
So maybe participants can look in that matter too.
Yeah, it is only we are charging to HPC only, not for the software. But that way only you can access full-fledged QuantumATK. That is the gateway to access QuantumATK. Yeah.
Yeah, thank you, sir. So is that clear, or should we repeat about the software?
I think only from the group only 8 people are requested this QuantumATK, but I am requesting all of you, only those all of 24 people to access this QuantumATK. Otherwise, you are not experience the real content of this workshop session. Yeah.
Yeah, that is the point. See, whatever the way you are accessing the QuantumATK, you need a QuantumATK software to understand all the things throughout the workshop.
And to perform the assignment task also.
Exactly. So it is not a lecture just to listen. You have to work even after the workshop, even after the live session. You have to
We
work
will
on
give
that.
you, yeah, we will give you a couple of assignments. Yeah.
So you have to make sure that you have an access to QuantumATK. whether it is your institute and or somehow, I mean, the one we are providing is we are collaborating with MG University and the MGU Paramastra we are accessing. And
And you are getting a very authenticated one. It's not a pirated one. It's not a trial one. Very authenticated software you can experience for a 1 month time. Yeah.
Even I think Sujit, who said he installed the trial version.
Yes, sir.
Yeah, Sujit, maybe you can also try with the trial version, how much calculations you can do, and
Yes,
what are the limitations. I didn't use the trial version, so I don't know what are the limitations. And definitely you can guide the other participants how to do that.
Sir, I have a couple of questions.
Sure.
Yeah.
And sir, first one is, can we use QuantumATK for biohybrids? Like, for example, protein chromophore coupled nanomaterials?
No. Not
Oh.
for that kind of biomaterials. You can use that. Yeah.
Okay, then secondly, why can't QuantumATK use to predict photoluminescence properties while Gaussian can?
It doesn't have that library actually. TDDFT library is not existing. Yeah. Yeah.
Then, sir, in the slides, could you maybe share this slide?
Yes. This already recorded session. After this thing, recorded session will be it's accessible, no? Yeah.
No. I want to refer to the slides that you have shared. Just
Slides also accessible. Yeah. We will share.
No.
After this.
Sir, what I mean is, can you please share your screen again with the slides?
Oh. Yeah. 1 minute. Yes.
So if you go back to where maybe 2 slides up.
Which slide?
No, go down. Sir, just a couple of next slide. Back 22. No, sir.
22.
No, go down, sir.
Yeah.
Sir, here you mentioned 22, 23. Here you mentioned this DFT employs QuantumATK employs this. So from Schrodinger equation, we basically find out psi, right?
Mm-hmm.
Whereas in this, we use the energy density. Energy distribution. Electron distribution, right?
Hmm.
Does that mean psi square or psi? Do you get what I mean?
Here, yeah, that part I understood. This DFT calculator is not a density. The basic thing is like that. Other thing is like a density distribution here calculating. Here, not a distribution here calculating, because it's a many body system. It's not for a small system for here calculating. It's a bulk configuration intended for. It's not for a small molecule here. Small molecule is not suitable for QuantumATK. Basically, is much suitable for a bulk configuration. That's why it's a LCO calculator employs linear combination of atomic orbitals. It's a bulk configuration we are employs instead of a DFT basis set. Yeah.
So that means we are basically targeting psi square rather than psi.
Correct. That equation wise, I will explain in detail. If you want that level of explanation, then I will explain by tomorrow's class. If you want that level of explanation, but I thought like this is introduction session because many of the other people are not experienced about this. What is a function? If you want that much level of depth in detail, then I will explain by tomorrow's session. What is the basis and how the equation comes, how the equation forms. If you want that level.
Yeah. Yes. I mean that would be good, but if you want to dig, if you have to
Yeah,
incorporate this into a
some
class.
extent I can go, because that type of time is not with us, because that calculation you need to show. The session, quantum ATK session is intended for just to guide you how to do a simple simulation with the quantum ATK, and you have to perform what are the all possible ways to calculate quantum ATK. Because if we am covering each session, it won't end up within 10 days or 12 days program, because it's a much more things you can do.
I
So
think tomorrow we can touch upon these topics. However, going in depth may not be justifiable to the workshop. Then it may be a theory course rather than a workshop.
yeah, correct. Because if you are explaining that much theory, then it's a much boring to many people.
And yeah, nowadays, I don't know, people can take there are a
Otherwise
couple of
you can see
NPTEL
the
courses.
result. Like a band structure I shown, na? Likewise you can show, I will show the result, and you study very well, because all these tutorials are available throughout the net actually. So we are giving the experience to quantum ATK, because there is no step is available how to perform quantum ATK. So we are giving the familiarization session in a practical ways, how you can do a simulation in a quantum ATK by using quantum ATK, other than tutorial. Yeah, if you want that, I will explain, no problem. Yeah,
Yeah, tomorrow we can. You also said the basis set.
basis set.
Course,
Yeah,
right?
yeah,
So tomorrow we
basis
can
set,
touch on.
and this a mathematical function also I will explain.
Yeah.
What is the difference? Yeah, yeah, mathematically I will explain. Yeah.
So, dear participants, you have to understand this point. It is we want to make it completely a quantum TK discussion. Definitely, there are many basic things we have to know before exploring the computational chemistry or physics. However, we can't explore all these things, but we can. I mean, I can suggest some NPTEL course related to the
Yeah,
computational chemistry
what is my
or
way of
quantum chemistry.
point is, at least you read from your end what is a basis set, what is exchange correlation functional, what is a different type of theoretical models. Just you before attending the class, you basic knowledge is something you attain. Then it will be much easier to discuss. Actually, everything we can't discuss from a scratch. Then it will be a quantum mechanics class. It's such a boring class. So before that, you just read about the basic things, and you ask, come for a doubt actually. So that doubt we can clear in the webinars. Okay. Yeah.
Sanu sir, one more thing. So those who paid for HPC access, they have to register, or we will
Yeah,
circulate.
they have to register. Compulsorily, you have to register. Then
Okay.
only we can create an account for you. There you can find it out. What are the coins? What are the wallets? Which kind of a job ID you are performing? Everything you can see that transparently.
So
Yeah.
can you share those links in WhatsApp group? And definitely we will circulate with all the participants through
Yes,
email.
yes. I immediately after this session, I will share in a WhatsApp group.
Sure.
Yeah.
So you can we can also make a SOP how to do those things, registration, even though it is
Okay.
not.
Sir,
Some participants may not.
in the registration part regarding in the dashboard, there is a thing about computing platform requirements, like what we need to fill in that section.
This computing platform requirement OS, you want to select just a Red Hat. And I think my screen is not visible now. One minute. I'm sharing.
Yeah.
Yeah.
Sanu sir, we have one SOP, right?
Yes, we have SOP. SOP
so can
I
you,
will.
yeah.
But
Can you just
it's already available in this one. When you go to dashboard, I think it's visible now.
yes,
Yeah.
you can see.
Paramastra HPC enrollment workflow we have published here. Step 1 is user has to register. Step 2 is a scrutiny. Step 3 is a payment. Step 4 is a HPC login credential. Step 5 is accessing. So everything we have explicitly written on this one. So you can just read and go through. And account registration, you just go here, and computational requirement type of OS Red Hat. CPU core, you are in a belongs to a basic plan, so 64. GPU nil 0. RAM is 64. Storage is 500. Node is 1. Type of HPC is on premise. and your requirement is QuantumATK. Just you type QuantumATK, QuantumATK. Then you submit the session. Okay. Any doubt now?
Excuse me, sir.
Yeah.
Sir, I already attended the Gaussian workshop and I have access to the HPC. So,
But that access will expire because I already got that your session is expired actually, but we never disconnected. But immediately it will get disconnect.
okay, so should I register again?
Yeah. You have to register. You have to just pay that. You no need to register. You can extend that session. If you just write an
Actually,
email after the payment,
for
3,000, you just write an email, then we will extend the session. Yeah.
Okay, sir.
Yeah. Any doubt?
Just one thing.
Yeah.
Actually, I was looking at, can you access VASP also on Paramastra? Can you do VASP calculations on Paramastra as well?
Yeah. You can do VASP calculation also.
In that case, I'm just saying maximum 64 GB. But if you use some hybrid function or something, is it possible to go beyond 64? And
Yeah. You can go for beyond that, and then you have to select a different plan. You got to go to advanced plan. Otherwise, you want to go to professional plan.
What about
Here,
storage? Because some of the bands calculation requires few hundred GB. So what about the storage?
This GB and the storage is that we are basic plan. We are limiting 500 MB.
Okay.
If you are a regular customer of us, there is no limitation for storage. There is no limitation for RAM.
Okay, great.
But it's for a webinar purpose. We are limiting it. Yeah.
Okay. Thank you.
Yeah. Okay, then Sabil sir.
Yes, sir. Yeah. So anyway,
I request you, all of you, enroll to Paramastra and report to CS Research Forum. Then immediately we can set it up QuantumATK access. Then everyone can familiarize as a authorized one. Because in terms of software, I'm not recommending any trial access or this kind of pirate access. So everything should be, because we, being a researcher, being a academic background, we have to follow some ethics. So that's why you have to familiarize with this much less cost we are providing. And QuantumATK people also know that we are providing for this strictly academic purpose. That's why we can offer this much inexpensive, very least price. Yeah.
Yeah, thank you so much, Sanay sir. So the dear participants, especially those who joined little late, you will get the recordings tomorrow morning. And to access the recordings, you have to log into the YouTube. We will share the YouTube link. However, to access that YouTube, you have to log into the YouTube with registered email ID. So make sure that the registered email ID has a Google account, or if you register with Institute email ID, please share your Gmail ID, personal Gmail ID. That is quite easy for us for the communication. And second thing is about the QuantumATK software. At least in coming sessions, make sure that you have access to QuantumATK. I think the coming session, tomorrow's session, also a little bit theory. As we discussed earlier, some basis set, some few basic understanding of the Schrodinger equation, quantum chemistry. Yeah, so the coming days, those who paid the SPC access, yeah, they have to register their own. And second, from Paramastra end, they will activate the access to QuantumATK. And in coming days, we'll discuss how to use those softwares. And today's session, Sanu sir just shown the process. Definitely for the beginners, it may be a little high. I don't know, but coming days we will do those processes, and we will make sure that those things are a little easy. Yeah, with this, we are winding up today's session. Thank you so much, Sanu sir. And
Yeah,
we'll look-
tomorrow we will explain every step. Now I shown very much faster, but I
Yes,
will
yes.
show step by
Maybe
step by
some-
step. I will explain. Yeah.
yeah, some of the participants they may feel that, oh, this is too much to do, and it's too fast.
No. Step by step, I will explain. So, yeah.
So it is just to show that how the process is, and the coming days we will do the little slow, and whether it is slow or fast, the important thing is you need a access to QuantumATK. So make sure that you have that one in coming classes. Yeah, that's it. Happy learning, and see you all tomorrow. Thank you, Sanu sir. We'll meet tomorrow.
Yeah. Thank you, everyone. See you in the next session.
Yeah, and we all, even Sanu sir is there in the WhatsApp group. So whenever you are facing any issues, you can.
Yeah.
share
Anytime
your thoughts
you
or
can
any-
ask now. No problem. No problem.
Thank you so much, sir. Thank you so much.
Yeah.
Okay. And those who install the trial version, they can also help the others how to do that. I don't know how much useful it is, but yeah, that's how we learn things. Okay then, see you.